Hello, welcome back. Today we're doing example 2, determining the roots, which are x-intercepts of the quadratic equation. So we all know what x-intercepts are. This will be the first time solving one quadratic, and we're going to verify our answers. Verifying your answers are just checking your work, just like you did when you did linear equation and you solved. It's the same idea. So we're going to start off with this one here. All right. And what we're going to do is we're going to solve this as we work here. Okay. So what you want to do is you want to get all the x's to one side and we'll make one side 0. That's how you solve for roots. Okay? There's no x and y. If there was a case, then you would get y by itself and have the rest on the other side. So that's what we're going to look at right now. All right? So the first thing to do is do a distributive property here. All right? And then we'll collect like terms. Okay? So first step would be to multiply the 2x by 4 and the 2x by negative x. Step 1. Step number 2, actually multiply them. 2x times 4 is 8x, and 2x times x is negative 2x squared. All right? Now we'll combine like terms, so we'll get everything to one side of the equation. So I want to keep the x's positive, so I'll bring everything over here and let the right side equal 0. It doesn't matter what side you do. So the next step would be to get rid of the x squared and get rid of the 8x. So I'm going to subtract. Subtract 8x. And subtract 2x. And we're going to square that. Okay. What you do to one side, you got to make sure you do to the other. All right. I should do that down here. It's no big deal. Take this here. Sorry, just have them in the wrong spot. So, and then whatever you do to one side, do to the other. So the minus 8x, you want to combine like terms, so it goes with the minus 6x. And the minus 2x, or we're going to add, sorry, because it was already negative, so we're going to add, my bad. And then we'll add 2x squared to both sides. All right, and then these are the zero principal. And that's why we did it. These become the zero principal. They're gone. So we're left with, combine like terms. 3x squared plus 2x squared is 5x squared. Minus 6x minus 8x is minus 14x. Plus 5 equals 0. Right? This whole side is going to 0. So to solve that graphically, we have to take this, and when the side's equal to 0, then we just set that equal to y. So we let y equal 0 in your graphing technology. That's how it has to go in. Okay? And there we are. And this is what we're putting in our graphing calculator. Okay? So I'll do it in the graphic technology. I'll do it with Desmos so you see both. All right, so you have both methods. Okay? So method 1, just like we did last question, I'm going to grab that. Method 1, using the TI-84 calculator. All right? So I'm going to do step by step in the process, and you folks can, obviously you're going to watch in class, but you can watch the video if you're absent as well. Okay? So we up there. We have our last graph from last time. Just hit clear it. Clear a couple times. Hit y equals, and you can just clear that now. Okay? If you want to clear the whole calculator, you can. Second function plus 7, 1, 2, and it's reset. Simple as that. So we go y equals, now we're reset to the factory setting. We go 5x squared minus 14x plus 5. We graph it. There it is. Pretty good graph. Again, get rid of it. We can change the window. We don't need all this. We don't need all that. We don't need this, right? So maybe you just make this, let's say, negative 2. Make this 4. Make this negative 5. So I'll show you how to do that. So the x, we said negative 2 is enough. 4 is enough. And again, you don't have to do this, but I just want to show you I like spreading the graph out the biggest I can on the page. And the y min, I think I said -5 is more than enough. And just hit graph. And then everything else can stay the same. I change this from -10 to -2. Change that from 10 to 4. Left that at 1. Made that -10 to 10 is fine here. Graph it. It just spreads it out a little bit, in my opinion. All right. So now what we want to do is we want to find the x-intercepts, the zeros. That's right here, where it crosses the x-axis. So I'm going to show you how to do that. Second function calc. And it says zeros, number 2. Zeros, x-intercepts. So we get the first one. There it is. Left bound. It'll come above or to the left of the x-axis. Hit enter. Then it'll say right bound. Go below and to the right of the x-axis. Hit enter for a third time. And there is your point. So your first x-intercept is 0.42. Okay? 0.42. And then your second intercept there, x-intercept is second function calc. We'll do it again. 0. And this time you're left bound. So you're using your right cursor. You can see the button up here. Going to the right. Till you're just, below or to the left. Hit enter. Keep going to the right. Hit enter for a third time and final time. And my answer now again, this is 2.78 or 2.38. But this, sometimes you get a weird number that represents 0 for y as well. I don't know why it does it. And again, one of the limitations on the I-84 why I love Desmos. But anyway, there it is. Okay. So I'm going to go back and do the other one again because that's the one I want to show on my sheet, not the one that doesn't look like a 0. So here we go. So remember, enter, go right and underneath, enter for 3 times, and there we go. So I'll take a picture of that one for our calculator to see what we get. All right. Okay. And you can look at those steps. And then the next thing we're going to do is in method 2, we're going to use my favorite, using Desmos technology, desmos.com. Right? It's just such a smooth way to do this. So we're going to graph this equation right here, Desmos. A copy, but you can take it over for me. Open up my Desmos program. Still my equation from last. So I just hit the X button. And there it is. There's my graph. So then you can just put plus and minus in the top right hand corner here, right? You do the plus minus in the top right hand corner. Get you where you need to be. But I think that graph looks pretty good. All right there. And here's what I love. Just click. Take your mouse, click on it, and then a couple other neat points that have some significance, and we'll talk about those later on. Now, the y-axis, that went all the way up to 90. Like I said, you might only want to put 20 there, okay, just to spread it out. What I like to do sometimes is I'll start it right from scratch again. If I use those, I hit desmos.com, just hit graphic technology, put the function in, and there we go, right? Okay, you can make it any color you want. Just hold it there, right? And there we go. And there's your graph. Again, a little steep, but again, you can spread that out if you wish. It's fine. So I'll take your graph, right? Hit the tool button in the top right-hand corner, like I showed in the previous video. Okay. And if you want to spread that out again, you can. It's up to you. So I can make this like this y, I can make that -6, right? Oh, -6, and I can make this like 10, right? And then I can spread the x out a little bit, because I didn't really go too far, so I can make it like -2. I can make this, I can do this as like 5, right? Okay, again, it doesn't make a difference. And then just click on your mouse, right click, and those are the important points. We'll talk about this is the y-intercept, 0 and 5. This is what we asked for, the 2 zeros or the 2 x-intercepts. 0.42 and 0, 2.38 and 0. And that's called the vertex again, so I just wanted to take a picture of them. As soon as you move, they're gone, but you can just re-click. I'm going to take a quick picture of that for our notes. All right. And there we go. Okay. Take this down here for it. There we go. Perfect. There's our graph, right? So to answer the question on both, it asks for the solutions. So it says determine the roots. So the roots are, remember that's the x-intercept, right? Steps for, just so you know what I'm referring to. Okay. We'll talk about more of the differences in pre-cal 11 if you decide to take that course. All right. So the roots, the x-intercepts, and that is at 0.42 and 0, and 2.38 and 0. Okay. So it didn't tell me to round, and I just pull it out here. And remember, the y-intercept is 0 and 5, and the vertex, if it asks, is 1.4 and negative 4.8. Okay. I also mentioned if you could try to check those, right? Check. Or verify, I said verify. Okay. So verify, how to verify these is just plug them back into the original, the very first one we had, right? So plug them in, and I'll do one example. I won't do them both. So plug in 0.42. Again, if you took the exact value you had, this was rounded, so it's going to be a little bit off. 0.42 multiplied by 0.42 minus 4, subtract 0.42. All right. So we'll do that math there. So I'm going to verify x equal to 0.42, right? That was one of the ones we found. Not doing both. You could try the other calculation, but I'll show one sample calculation. So everywhere I see x, I plug in. So I went up to the original equation, as you remember, right? Went up to the original, and I plug those numbers in for x, all right? So we're going to calculate that. So verify and plug it in, and you'll notice I get both sides are actually supposed to equal 3 is equal to 3, but the reason it didn't work is because I rounded, right? I did some rounding throughout. This is not the exact value, so not a great one to verify, but it's easier super close like that. Even in one place after the decimal, which they would both be 3 equals 3. So if I had to round this to one place after the decimal, I would have 3.0 is equal to 3.0, right? And again, that's just because this was rounded. That's why that didn't work. So when we come back in the next video, I'm going to do another method, and that is when we solve, when they're not in standard form, doing two separate functions, which I love. It's very straightforward, all right, and easy to work with. Okay, so remember this method here we did. I showed it both ways, so I guess we'll call it method A, and then method 1A, I guess, right, or A1. So this was actually when we left it in what's called the standard form, right? So set, and I talked about this before, set equation equal to 0, like I mentioned in the video, by putting in standard form. So setting equal to 0, right? And then I showed it two ways. We'll call it A and B, 1A, 1B, right? Or actually, maybe I'll call this method 1, and I'll call this 1A and 1B. That might be better, yeah. We'll do it that way. Okay? So, and I just showed it using two different types of technology. All right? So we'll do that in the next video. I hope it's helping, and we'll talk again soon.